Hello guys, welcome back. Today we are going to understand today Leetcode question. Today we have the Leetcode question is 1721 and we have to do the swapping of nodes in a linked list. Means we have given a head of the linked list and integer k. As you can see in the input, right, we have given head is 1 2 3 4 5 and k equal to 2. Now it is saying that return the head of the linked list after swapping the value of kth node from the beginning and kth node from the end of the node, right? So we have to do, means we have given kth node, we have to do from swapping, right? So if we'll do the swapping, right, kth node means we are talking about this node, right? So this node is going to swap like this with this one, right, like this. So after swapping this one, this will come to this position, right? And that's why we are getting here 4. Okay, so we have to return this resulting linked list in the output, and that's what we are getting like this. Okay, similarly if we have given 7 9 6 6 7 8 3 0 3 0 9 5 like this. Okay, so we have given 9 5, right? Means we have to do the swapping. So as you can see, what we have given, if k equal to 5, 0 1 2 3 4 5 6 7 8 9, means we are talking about this 7. Okay, so this 7 will get swap. So if we'll do the swapping, so as you can see, rest of the element is remaining same, right? 3095 and here 3095 is same, right? Only what is happening, we are swapping these two. So 8 is 7 is, so 7, this 7 and 8 is getting swap. This 7 and 8 is going to swap like this, right? So after the swapping we have to return. So how we will do the swapping, that we will see here in this video. Okay, so let's continue understand the swapping. So this is a very simple problem actually, and this question has been asked in all the top companies, in the product based companies, right? Adobe has asked 3 times, Amazon, Facebook, Bloomberg, Microsoft, Oracle, right? These top companies have asked this question, right? So you have to focus on the given constant, right, and the question statement, right? So this problem is based on the linked list data structure, right? So if you haven't solved if you have solved some problems using linked list and using the basic data structure idea, like how linked list is diverse and modified, right? So this problem will be easy for you to implement. Okay, but the general idea behind the problem is we have to find kth node, right? We have given here, right? So from the kth node, you can say, to the end of the linked list, right? Once we have pointers to both of these nodes, we could simply swap their values. So the problem description states that we have to swap the value of the nodes, right? And therefore the actual nodes in the linked list should remain unchanged. So there is no need to change the actual node pointer, right? So what we will go in this session, we are going to look at 3 different approaches, right? So each approach further will reduce the number of passes we need to go through in the list. So first of all, we'll go to see the approach 1, in which we are going to see 3 passes, right? So this some people also used to say 3 pass approach, right? So what we are going to do in this approach, so we have given a problem to swap 2 nodes. Let's suppose we have given 2 nodes and we have to do swap, right? So in the linked list with the kth position. Okay, so we have given kth position. As you can see, we have given kth position. It means we need to position 2 pointers, actually, you can say, right? So the first pointer would be you can say kth node at the beginning of the list given by the front node, and the second pointer would be the kth node at the end of the given by its end node, right? So as you can see, this is the head. If this is the head, so front node will become what? This one, and the end node will become this one, right? So in this way, what we will do, we'll take 2 pointers and we'll do the swapping, right? How we'll do that, we will see later. But first we have to understand this one. So finding the position of front node is simple, right? So we can start traversing from the head node until we reach the kth node we have given into the linked list, right? But to find the AND node, we must first know the length of the linked list. So if the length of the linked list is let's suppose we take some value, right? List length will take here, right? So if we know this list length is 6, right? So what we will know, list length minus k will do, and that will come your AND node, right? So that you have to understand here. Okay, so first of all, what I'm going to say means first front node, you know, right? Because this is the beginning of the, from the beginning of the node you can count and you can get it, right? But for the AND node, if we'll talk about this one, we have to know list length, and from there we'll do minus k, so you will get the AND node, right? Like this. So remember these two things. Okay, so if you have understand here, so let's continue now. So we first know the length of the linked list. If the length of the linked list we know, so kth node from the AND would be the length list length minus k for the kth node, right? As you can see here in this picture, right? Now you have to focus about how we'll do the traversing, right? So that we will see how we will do. So in the first pass, right, what we have to do, we will take 3 passes, right? First pass is what we will do. So we will find the length of the list by traversing each node in the list from the head, from here to the last one. Okay, we'll go and will increment the counter by 1, right? So the length could be counted to find, we can find the list of the length, right? Now what we have to do in the pass 3, sorry, in the pass 2, this is pass 1 in which we will find the list length. So in the pass 2, what we will do, we will traverse until kth node from the head will reach, and we'll set the front node. So once we will start traversing like this, so we will reach to the front node and we'll say, yeah, the kth node will cover, and this is your front node, right? Once this is reached, right, then what we will do, we'll traverse until the list length minus 1 will get, sorry, list length minus length will get, and that will your you can say AND node, right? So from you can say list length minus k, as you can see here we have done here, right? That will is nothing but what, the AND node, right? So we have our front node and AND node, and then we will do the swapping with the front and the AND using a temporary variable, and we will return the head of this, right? So let's go to the browser and we'll do the implementation, so it will become a little easy for you to implement this one. So let's continue here on the browser side. Okay, so as you can see, we have given the list node, and the list node is containing variable, and another is a next pointer, and these 3 things we have to create a node, right, as a constructor. So I'll hide this one and we'll continue from here. Okay, so first of all, what we have to do, we have given the head of the linked list, right, and the kth position we have given, right? To do that, what we have to do, first of all, we have to find the list length, right? So what I'll do, I'll create one int list, and that is nothing but our length. I'll do list length, and that is nothing but our 0. Another, what we have, list node, we will find from the list node, right? This is list node, so head we have given. So what we should do, we will create our list node that is for the current node, right? Let's suppose this is nothing but your current node. Okay, so if you have the current node, right, and if this current node is, will start from what, nothing but our node, right? So, sorry, head, not node, that is head. So I will start my current node from head, right? So let me not like this. You can take the variable like this. So this is your current node, and I'm going to start my current node from head. Okay, right? Either I'll, yeah, good. Now what we should do, once we have our current node, so we have started with the current node from what, head. Now we have to find the length of the list. To do that, in the linked list, what we have to do, we'll do while loop, so that we will not reach to the in the loop, we will not into the infinite loop, and we'll say if the current node we have, right, this is your current node, and if current node is nothing but it's null, means if we are not null, means we have to increment our length, list length. So list length will do list length plus will do. So each time once we will find the new node and that is not null, means we'll increment the length, and then we'll go to our current node, and this current node is become what, equal to current node dot will do there is a next as a to find the next node, right? To find the next node we'll loop like this. So each time from the current node we'll move to the next node, so we'll reach there. I will explain visually. So first let's continue to understand each line of the coding, so you will have the understanding. Okay, once we will reach here, we have to set the front node at the kth node and from the at the kth node, right? So this is the pass one. So as I told you, so pass one, what we have to do, we have to set front node, right? Front node, you can say, at kth node, right? That we have given. To do that, what we have to do, we will take a front node, and that is nothing but your list node, right? So here, and this is nothing but our you can say front node, right? Front node, like this. I'll rename like this. Okay, so this is your front node. I'll start from where? Head. To set this, what we have to do, we have to go with the for loop. I'll start int I equal to 0, and we should go to I should less than k and I plus plus, like this. And here what we will do, we will set the value, right? So I'll do the front node, and this front node is nothing but what? Let front node dot next will do like this. So once we have the front node dot next, I'll do. So you will have you will reach to the front node, because till k we have to do. How many nodes we have to do? Only 0 to kth position, right? So you will have your node, right? Front node. Similarly, we have to set in pass 2. What we will do, we'll set and node at from kth. Sorry, you can say at what? List length that we have already calculated minus kth, right? So this is the thing that we are talking about in this presentation, right? So kth node, we have to add the kth node will reach, right? To do that, what we will do, so you have the list node, and that is nothing about node end node, and this end node will start from the head, and we'll take a for loop, and we'll say int I equal to what? I will start from 1. Okay, yeah, we should also start with 1 here, because this is not array, this is linked list, right? So we have to start like this. So we'll do what? I should be less than what? It's list length, right? List length, and we can do minus k, you will get, and then I plus plus, like this. So we'll reach the last length, and we'll say this is your end node, and the end node is nothing but your end node dot next, right? Like this. So we will reach to the last node. Now in the pass 3, we know that what we have to do, we have to, in the pass 3, you will do swap, right? To swap the value of the front node and node, right? You will do. So if you want int temp and equal to front node dot val, I'll do front node dot val, and then we'll read what? Front node dot val equal to what? Temp. We will not in the temp, we will copy from the end node, right? This is your end dot val, right? That will come from there, and the end node value will come to what? We have already calculated the first node. Now end node is already on the first node, so this val will be nothing your temp data, because we have already swapped, and then we will return head, right? Let me zoom out. So what I have did here, so in the first pass we will set the front node, in the second pass we'll set the end node, in the third pass what we will do, we'll do the swapping. We will take a temp variable, we'll store the front value, and on the front value we'll store the end value. Now what we'll do at the end, we'll store the temp value. So this is swap. We know that this is the swapping thing, so that is easy. And finally we'll write on the head, that is your answer, right? So this is all we have in this coding section. Let's run this one, and then we will understand the visual thing. Okay, is it working? Yeah, it's working. Thank you. And let's continue to understand your you can say time complexity thing. Okay.